Hi everyone, welcome back. In this video, you'll learn how to use Python code to automate repetitive tasks. Rather than write new code each time you want to make the calculation, you can instead write an iterative statement or loop. Using Python to automate repetitive tasks saves tons of time and effort and reduces the risk of human error. We'll discuss two types of loops, while loops and for loops. As a refresher, a loop is a block of code used to carry out iterations. An iteration is the repeated execution of a set of statements, where one iteration is the single execution of a block of code. And an iterable is an object that's looped or iterated over. Typically, data professionals use for loops and while loops to work with iterables. Let's start with while loops. A while loop is a loop that instructs your computer to continuously execute your code based on the value of a condition. While loops work in a similar way to branching if statements. The difference is that, in while loops, the body of the block can be executed multiple times instead of just once. This is great for avoiding redundancy in code. Let's review an example. Assign the value of 0 to the variable x. As you've learned, we call this action initializing to give an initial value to a variable. Next, start the while loop. Set a condition for this loop that x needs to be less than 5. The prior line just initialized it, so this condition is currently true. Then, end the while loop line with a colon. On the next two lines, you may notice a block that's indented to the right. This is the while loop's body. There are two lines in the body of the loop. In the first line, print a message followed by the current value of x. In the second line, increment the value of x by adding 1 to its current value and assigning it back to x. In the body of the while loop, we told the computer to print the results of each iteration. Notice how each iteration changed the value of x. Our while loop started at x equals 0, then printed the message, and increments the value of x to 1. But because this is a loop, the computer doesn't just continue executing with the next line in the script. Instead, it loops back around to reevaluate the condition for the while loop. This is the second iteration. And because 1 here is still less than 5, it executes the body of the loop again. The third iteration increments x by 1. Now the value of x is 2. The computer will keep doing this until the condition isn't true anymore. Let's add a print statement outside the body of the while loop to let us know the final value of x. When the loop finishes, the next line of code is executed. So, now that x has reached the value 5, the loop statement ends. The computer prints the last line of output as x equals 5. We can also use the logical operators and, or, and not that we worked with earlier, similar to if statements. Using these operators allows us to combine the values of several expressions to get the result we want. The important thing to remember is that the condition used by the while loop needs to evaluate to true or false. It doesn't matter if this is done by using comparison operators or calling additional functions. I think you're ready for an example that uses several different concepts. You can pause the video and try to figure out what this code is doing. When you're ready, continue and I'll lead you through it. In this example, we're going to write a short program that generates a random number and then gives the user 5 chances to guess it. We begin by importing a package called random. This package has many uses, but the one we want is its ability to generate a random number. Now instantiate a variable called number and use the randomInt function from the random package to assign it a value. The value is a random number between 1 and 25, inclusive. Next, we instantiate another variable called number of guesses and assign it a value of 0. This variable is important because it will behave as a counter that controls the logic of our program. Now the while loop. We write while the number of guesses is less than 5, and below it we give the instructions for what should happen at each iteration of the loop. First, the script will print a message telling the user to guess a number from 1 to 25. Then we instantiate a new variable called guess, which will capture a string of whatever the user inputs. The input function used here will create a prompt that allows the user to type their guess. The next line converts the guess to an integer. This is important because without it, the input function would capture the number as a string, and it would be impossible to win the game, because even if they guess the right number, the string of a number will never evaluate as being equal to the integer of the number. Now, we increase the number of guesses variable by 1. This is an important step because, remember, the while loop will continue to iterate for as long as the number of guesses variable is less than 5. If we left this out, the loop would never stop running, and the user would have infinite guesses until they got it right. By the way, this syntax is a helpful shortcut. Instead of writing number of guesses equals number of guesses plus 1, we can simply write number of guesses plus equals 1. They mean the same thing, but one way is shorter. Now we're going to have our branching logic that determines what the program does. We want the behavior to be different depending on how many guesses the user has made and whether their guess was correct or not. This code is still within the body of the while loop, so we'll execute on every iteration. The first line checks if the guess is correct. If it is, the while loop breaks. This word break is a keyword that lets you escape a loop without triggering any else statement that follows it in the loop. In this case, if the user guesses the correct number, the while loop would break and the code would continue at the if statement below. Because the guess is correct, we print a message telling the user that they're correct and include how many tries it took them in the message. But let's go back up to the while loop and go through what happens if the guess is not correct. We use the elif statement to check if the guess was their fifth guess. If it was, we break the while loop. Evaluation would continue below, and because the guess was incorrect, it would trigger the very last else statement that outputs a message telling the user they were unsuccessful and revealing the correct number. Without this elif statement, the code would still work. The user would get a message saying, "Nope, try again," and then immediately get another message telling them they were unsuccessful and revealing the number. But if the guess was not their fifth guess, the code would proceed to the else statement, which prints "Nope, try again." Let's run the program and try to guess the number. Great, you just integrated a bunch of concepts into a single script of code and worked on a problem that incorporated some complex logic. These skills are invaluable to data professionals. Let's move on and discuss for loops. Have you ever tried to withdraw money from your bank's ATM, but keyed in your password incorrectly? As you probably experienced, you only have a certain number of tries before the system will lock you out. Sure, it's frustrating if you're just typing too quickly or temporarily forget your PIN, but it's a great safeguard that helps protect your bank accounts. Well, the software in many cash machines runs using a for loop. This detects how many attempts have been made on a single transaction before blocking the user. Now, we're going to learn how that works. A for loop iterates over a sequence of values. A simple example of a for loop is to iterate over a sequence of numbers. For x in range 5, print x. Notice how the structure of a for loop is similar to the syntax of a typical Python statement. The first line indicates the distinguishing keyword, in this case for, and like functions and other expressions that start a distinct code block, it ends with a colon. The body of the for loop is indented to the right. What's different in this case is that we have the keyword in. Also, between the keywords for and in, we have the name of a variable, x. This variable will take each of the values in the sequence the loop iterates through. In this example, x takes the values 0, 1, 2, 3, and 4. We don't have to use x. We could use any term we want. In, number, monkey. It doesn't matter, as long as we maintain consistency between what we name it here and how we refer to it below. Okay, now let's examine the range function. The range function is a Python function that returns a sequence of numbers starting from 0, increments by 1 by default, and stops before the given number. It can be used in while or for loops. In Python and many other programming languages, a range of numbers will start with the value 0 by default. The list of numbers generated will be one less than the given value. Let's check it out. By default, our range function starts with 0. After the first iteration, the value will be 1, the second iteration outputs 2, and so forth. Whatever code we put in the body of the loop will be executed on each of the values, one value at a time. You can also use a for loop to read in a file and iterate over the file line by line. The with open statement uses the file path to read in the file. In this case, it's a text file containing the Zen of Python, a famous poem written by software engineer Tim Peters. For easier notation, assign it the value of f. Otherwise, we'd have to write the file path again. In the next line, start the for loop for each line. Inside, you indent, and on the next line, tell the computer to print each line. After the loop is complete, tell the computer to print done. Data professionals use for loops in Python and other programming languages all the time. They're one of the fundamental tools of coding. They're great for performing a repeated procedure on an object with a fixed length to create something new. Let's explore more ways to use loops. You won't always need to start with 0. Instead, you might want to use a step parameter in the range function. This makes it possible to specify which elements of a variable or dataset we want to start and end with. You'll learn how to use the 3 parameters of the range function: start value, stop value, and step value. Here's a for loop that calculates the factorial of 9. Let's explore how it works. We begin by assigning a variable called product with the number 1. Next, we have a range function that starts at 1 and stops at 10. Since the stop value is not included in the calculation, this means the code multiplies the variable by every whole number in the sequence beginning with 1 and ending with 9. So, for n in range 1 to 10, we multiply our product variable by 1 and reassign the result back to itself. Then, we multiply the product variable by 2 and reassign the result back to itself, then by 3, all the way up to 9. This produces the factorial of 9. The factorial of 9 equals 362,880. Note that we started with 1 and not with 0. If we multiply by 0, the product would be 0. The range function also lets us specify a third parameter to change the size of each step in our range. In other words, instead of going 1 by 1, you can have a larger difference between each of the values in your range. Let's explore an example. First, define a function that converts a temperature value from Fahrenheit to Celsius. Use the standard conversion formula. The temperature in Fahrenheit that needs to be converted is identified by x. 32 is subtracted from x times 5 divided by 9. Next, we have a for loop that will print a table of temperature conversions every 10 degrees from 0 to 100 degrees Fahrenheit. Notice that the for loop starts at 0 and goes up to 100 in steps of 10. Remember that the range excludes the final value in a sequence. So to include 100 in our sequence, we put the end value as 101. The body of the for loop prints the value in Fahrenheit and the value in Celsius to create a conversion table. For every 10 degrees Fahrenheit, the code prints the corresponding value in Celsius on each line. So, now you know more about setting parameters for the range function when you're working with for loops. As a quick reminder, use for loops when there's a sequence of elements that you want to iterate over. For example, to loop over a variable, such as a record in a dataset, it's always better to use for loops. This also improves the readability of your code. Use while loops when you want to repeat an action until a Boolean condition changes, without having to write the same code repeatedly. Remember, Booleans are a data type that represents one of 2 possible states, usually true or false. And if whatever you're trying to do can be done with either a for loop or a while loop, just use whatever you prefer. That's all for now. Don't forget to smash that like button, subscribe, and ring the bell to stay updated. In the next video, we will learn how to work with strings. Thanks for watching, and see you soon.